tell me here what they did to try to approximate the area. What is it that what did you try to start doing? What did you do, Matthew?
Made a triangle from the point where the vertical line and 0.
Like that?
Yeah.
Okay. All right. So that's probably the most common approach that people take. And so within that situation, you have 1/2 times the base, which is 10. What's the height?
9.5. It's a little below 9. 8.5, 8.7.
9.4868.
Yeah. So, Alyssa, how do you come up with the exact value of the height?
The original function's up there, and I plug it into the calculator and use the table.
Yeah. So you see 3 roots of x. So you can evaluate the exact height. The exact height is, in fact, 3 roots of 10. Is it not? So there is no approximation actually needed in that scenario. Okay. You got 3 roots of 10 exactly. So if you ever want to come up with that, you can do it. What did you do after that? Matthew, what did you do after that? Now you got like this thing.
I made another triangle from that same intersection point to about 0.4 on the line.
Where?
I made a
right
line
here?
from there to, yeah.
To there?
Yeah.
Okay. All right. How'd you find that area? How'd you find that area?
I made a, what was it, I made a perpendicular line from the 0.4 down.
Okay.
To that, something like that.
All right.
And then I just sort of started guessing.
Okay. All right. All right. So we resorted to guessing after some point. Anybody take a different approach other than the initial triangle thought? Maybe try something other than a triangle.
Yeah.
What'd you do?
I started by drawing rectangles like width of 1 and extending up until like one of the corners touches the line, and then.
Okay. So hold on. So like
that, yeah.
Like that?
Yeah, and then finish it
like that. Okay. So that's a little bit of an overestimation, right?
A little bit, yeah.
Okay. So we've got. Anybody else kind of do some rectangles? Made a big rectangle? So when you said big rectangle like that, and then what did you do?
Well, I didn't plug it into the function. I did it at 9, so then half of that to make the triangle Matthew had was 45, and then I guessed for the rest.
And then you guessed for the rest. Okay, so still coming back to that big triangle in the middle and guessing. Okay, that's fine. Can I show you something that's going to work out very well for us? Okay, and you can have a lot of different ways of approaching this problem, but I want to continue off with this rectangle idea as I draw the black rectangles right here. Okay, and instead of doing all of them, we're just going to do a few. But I want to show you at this time that there's a couple different ways to draw the rectangles. Okay, if you notice, this bottom part here, okay, has a left side and a right side. Everybody see it? Is the height of the function determined by the left side or the right side? See how I do the right side of every interval gets up to that spot? Yeah, how many rectangles do we have? There's 10 of them. And suppose that what's the width of each rectangle? Yeah, you're going to have 1, and the width is 1, right? So you get 1 times, 1 times each height, right? So what's the first height? Like if, in order to figure out the height, Lisa already told us you just plug in 1, right? And so 3 times the square root of 1 is just 3. So that's the area of the first rectangle. So then I would add the area of the second rectangle. We have 1 times, what would we plug in there? 2 would get that, so you get 3 roots of 2, right? And then you would get 1 times 3 roots of 3, so on and so forth, all the way up to the square root of 10, right? Okay, that's what we do. Now, let's just admit, is this going to be an overestimation or an underestimation? This could be a ridiculous overestimation. What if we want to make it more accurate? What could we do with the rectangles in order to make it more accurate? We got two options. Oh, I heard three things. One, make them smaller so we could have more rectangles. Like do like 1,000 of them, right? That may sound ridiculous to do by hand, but if we have technology available to us, making 1,000 is that big of a deal. In fact, you will make 1,000 rectangles in this class eventually, okay? And it won't be a big deal. You said?
I just said chop it in half.
Chop it in half. What does that mean?
I don't know.
Okay.
I just said make it thinner rectangle.
Thinner?
With the red line, there's a triangle that appears to show up.
Yeah, let's look at Matthew's thought right there. So it is very important that you lean in here to see this. I'm going to draw it right here. So instead of drawing the height of the rectangle up at 10, I'm going to draw the height of the rectangle at 9. So see the difference between the rectangle drawn at 9 and the rectangle drawn at 10?
Should we bring Addie back in?
She's testing.
Oh, she's okay.
Yeah, but thank you. I would have forgotten that normally. So does everybody see that the black is an overestimation, but the purple is an underestimation? So what if we did both of them and then we average them? Oh, whoa, would that come out close? Yeah, in fact, I'll do it again just to give you a better idea and a better shape here. But suppose I'm at 4 and 5. This rectangle right here, the black one's drawn at 5, the purple one's drawn at 4, and then if you would average them, is that a pretty accurate estimate? Without a doubt. I mean, it's ridiculously accurate. Ridiculously accurate estimate. We call one of these a right-hand area. We call one of them a left-hand area. The black is a right-hand projection. The purple is a left-hand projection. And then we can average the two. And in fact, when you average the two, what shape, geometrical shape, does that make? It is a parallelogram. Trapezoid. Yeah, it makes a trapezoid. So all of a sudden, it looks like rectangles paired together, we come up with trapezoids, and that's a beautiful option as well, isn't it? And so you have to, at a moment, appreciate, and for all of you guys are different spots, okay? So talking to Gavin Kwame yesterday, he's taking the first of like 14 math classes to come, okay? So like he's in the math road for the long haul. So some of you guys, this will be the last math class you ever take. You have to pause and appreciate the moment. Whatever you're going to use math for, is that we're going to do something that's absolutely absurd. Matthew asked us, he said, what is the formula? He's regretting he didn't take calc. Should we let him back in?
No.
Should we let him back in?
You don't need to.
Should we let him back in?
No.
We'll kick him the curse.
Yeah, he's
Okay.
really
All right,
happy
great.
today. He's very enthusiastic.
Okay. So, what you have to appreciate, Matthew says, what's the area of a circle? And you say? Pi r squared. What's the area of a triangle? And you say? 1/2 base times height. We have all these formulas, don't we? Do we have a formula for that? Absolutely not. And with the development of calculus, Archimedes set this forth back in 200 BC. He said, we can find the area of any shape at all, not an estimate. We can find it exactly, absolutely exact, which is semi-ridiculous, but it is possible. And so within this class, we are going to move to a point where right here you see 10 triangle or 10 rectangles. We are going to move to an infinite number of rectangles.
I see it on TikTok. It was like calculus explaining it to a 10-year-old, and it was doing the shape of a pool.
Yeah, nice, awesome. And so as you see that, so here, watch the craziness here that happens. Okay, what do you think is going to happen to the width of the rectangles? The width of the rectangles approaches 0. It's 1 over infinity. Yet the sum of all the heights approaches infinity. And so we come to another infinity over infinity situation. And this time it is used to find the exact area underneath the curve. Which, if that doesn't blow your mind, then I don't know what does. But that's pretty cool. Take out your calculator so we can just look at the cool thing that Alyssa used to cheat. Okay?
Yeah, little cheater.
Okay, everybody point at Alyssa. Everybody please point and say cheater.
Cheater.
Cheater. Cheater. Okay? And let's see what the answer is here.
Why do we even know it?
63.724.
Yeah, well,
Facts.
exactly. So therefore, you know how to find the area using calculator, but you don't know calculus.
If I know calculator.
I had it at 59 and she said I'm full house.
When I
So I
asked
said
her that question,
63.
it says, yeah, you
This
don't
is
have to
random,
be in
17.
this class, so.
Yep. I mean, you can always drop. There's study halls available right now.
I can't have more than one study.
Type in 3 roots of x. Go be a TA for somebody. Take an underwater basket weaving class. You got 3 roots of x, 3 roots of x, 3 roots of x. I type it in. I'm going to zoom 6. Everybody zoom 6 so you make sure you see that function. And you are only going to use this for the time being to possibly check some of your answers. But come to the AP Calculus exam, this gets used all the time. You press second calculate. And we're going to use this crazy number 7 thing, whatever that heck that is. Okay? We're going to press 7. And it asks us our lower limit. We're starting to gather area at 0. And we're stopping to gather the area at a value of 10. What?
You get that part.
Okay, so second calculate. I choose number 7.
Satisfying to watch.
Is yours in colors?
And I press
Get colored in.
0. And I press 10. And you should get this beautiful
Oh, mine is more sad.
area that gets filled in. 63.2456. Let's look back at your guesses. 63.2454. You didn't cheat?
No, I literally guessed the last.
Everybody give it up for Rhea! And since Hannah came up with a different guess, we won't give her a prize.
That'd be so rude.
Each group gets 1 prize. You
We
put
were a
forth your
group, we
own.
worked together, but then like,
You decided to
Yeah,
differentiate
for
at some
real.
point.
You didn't
Okay?
want to go with my guess.
no, we were working together, but 2 different guesses gets us a better chance of getting right.
But we got some pretty good guesses there, okay? All right, some pretty good guesses there. So as we flip back here, I want you guys to flip over to this page, okay? And we're just,
Rhea, I can't believe you did.
today is really an introduction piece, but I do want to at least try to knock out the first example here, okay? So no assignment today. Say thank you, Mr. Gannon. You're welcome. But the area problem with calculus, there's really 2 big questions we ask in calculus. Number 1 is, what is the slope of a line tangent at a curve? And we found that out by using derivatives, right? The time of derivatives is basically done. Okay, we're not going to see derivatives a whole lot more.
Finally figured it out.
We are entirely moving on to a new thing, finding area, which is the study of integrals. You're in integral calculus now. And the big question that gets asked is this. Suppose we have a function, and it is f of x, and it is bounded by the line A and the line B, and it encloses this area right here. The big question that gets asked is, what is the area? And you will calculate this area, believe it or not, you'll calculate it exact. You'll calculate it exact by hand. Okay? And you'll do it like 3 different ways. And one way you're going to do is we're actually going to teach you how to work with an infinite number of rectangles, which should make your mind just melt in and of itself to think of that idea. So let's look at the most basic example here. Find the area bounded between the curve f of x is x squared, the x-axis, and the line x equals 4. So I have x squared and I have the line x equals 4. Didn't do a very good job there, did I? Was waiting for Lily to tell me how bad of a drawing I had.
Your drawing's really bad.
Thank you.
Wait, is this supposed to be to the exact?
Just doing my best.
Like, can
What?
it be like that?
Yeah, you're fine. Yep. Okay. We want to estimate this area here. And everything today and on Monday is going to be by making right triangles. We're only going to focus on I said right triangles. We're only going to focus on right-handed sums at this time. So all of your rectangles will be drawn to the right side. So here's what you want to first think of. We are going to draw 2 rectangles to approximate this area, just 2. What is going to be the width of each rectangle?
2.
How come? You had a total distance of 4 and you divided that into 2 spots, right? So I'm going to put a 2 there. And then I'm going to have this one rectangle here and that rectangle there. Overestimation or underestimation? Obviously an overestimation, right? Let's calculate the area. We have the width of the first one times a height plus the width of the second one times a height. You guys already told me the width of each one was 2. What is going to be the height of the first rectangle? 4. How'd you get that? You took 2 and you squared to get 4. What's the height of the second rectangle? 16. And so I get, and please watch at this point, I notice that the width is going to be the same every time. Agreed? So I could just have the width times the sum of the heights. That's going to save me just a little bit of work in the long run.
40.
So I have 2 times 20, which is 40. So the approximate area is 40. For the sake of time, let us skip 4 rectangles. Let's move on to 8 rectangles. You guys okay with that? What's going to be the width of each rectangle? 1/2. So we have 1/2 times, now we just need the sum of the heights. The sum of the heights. Let's see, if we divide this up into 8 spots, I'm going to have 1, I will have 1/2, I will have 3 halves, I will have 3, I'll have 5 halves, and I will have 7 halves. So how would you calculate the first height? 1/2 squared. And when you square a half, you get a 4th. How do you calculate the second height? And 1 squared is 1. The third height? 3/2 squared is 9/4. The fourth height? 2 squared would be 4. The fifth height? 25 over 4. The sixth height? 9er. The seventh height? Please just hold on through this. 49 over 4. And the last height? 16. Okay? Can somebody quick add those up on their calculator for me, please? And then divide by 2. As somebody is adding, can everybody recognize that the red is a much better estimation than the blue? Can everybody also recognize that both are in fact an overestimation at this time? So while this one will not give me the right answer, it'll give me a much cleaner answer. Does anybody have 1/2 times that sum?
25, 21,
25 and 1/8 sounds about right. If we have 4ths on the bottom, I thought it should be 2/5, but we'll finish it up on Monday. Okay, good job, everybody.